We're going to look at the distributive property today, and this distributive property allows us to algebraically connect addition with multiplication. Now there are some exponent rules that we'll need to know for some of the problems we're going to do today, so we just want to make sure that you know some of these, the two basic exponent rules. When we multiply exponents of the same base, we're going to add the exponents together. When we divide exponents of the same base, so I have base A and base A here, I'm going to take away the exponents because I'm going to take away the division, the divide on the bottom from the multiply on top. If I have A7 times A2, there's 7 A's multiplied here, there's 9 A's multiplied here, and they're connected by multiplication. So I can then connect that all by multiplication and count that as A9. Here I have y times y squared, that's connected by multiplication, times y cubed, that's connected by multiplication. Since this is all connected by multiplication, I can count the number of repeated multiplication by just adding together exponents. 1 plus 2 plus 3. When I divide, I want to do the division of the numbers separately with the division of power. So first thing is I'm going to divide 12 divided by 4. That's going to give me 3. I want to group together just the base A's because I need to count the number of A's being multiplied and divided. So here I have 8 times 4 divide. That leaves me with 4 multiplications. For the B's, I count the B's separately as well. So I'm counting the number of B's being multiplied and divided. I have 7 multiplied, 3 divide. So that means I have 4 B's multiplied together. When I have different bases, I can only group the A's together, and again it has to be connected by multiplication. Everything is connected by multiplication here, so I can count the A's as 5 A's being multiplied, or a to the power 5. The B's here, the B's are connected by multiplication as well, and so I can count the B's in multiplication. So I have 1 plus 5 is 6 B's. Okay, so those are the basics of exponent properties, and we're just going to use some of the basic ones. The main goal for today is looking at the distributive property, and most of us probably understand and know the distributive property when it comes to multiplication and box multiplication. But we want to connect this to algebraic processes. So we could solve this question. We can calculate this, and we can just say this is 5 plus 2 is 7. So we can do the brackets first, and we can multiply, and we get 21. And so 21 is the correct answer here. But sometimes we want to remove the brackets without actually doing the operation inside, and I'll show you why we would do that in a second. But if we want to do that, what I can say is, well, I'll draw out the picture here. Well, I have a side length of 3. This is my length. This represents my width. Multiplication is when I have length times width. Times is going to be the product, or the area. The product is the area of multiplication. And I can split up that 5 plus 2 like this. And I can see that I have an area of 15 and an area of 6. And I can decompose that multiplication that way. And that's perfectly fine to do that. When I do that, I can actually, instead of adding the 5 plus 2 first, I can distribute the 3 into there. And I get 15 plus 6, which is what I have here. I'm just going to do that in the same color because this is really doing the same thing. And when I do that, I get the answer of 21. So it's exactly the same as if I did BEDMAS. Okay? And this is perfectly valid. We can see geometrically and visually that this is actually that this works, and this is perfectly valid mathematically. So why would we want to do this? Because we can just add first. BEDMAS tells us to add first and then multiply second. Well, there are some situations where we cannot add first. So for example here, I have 3 times a plus 2. Well, I cannot add a plus 2. They are not like terms, they cannot be added together, so I cannot add this before I want to multiply. However, since we can talk about multiplication as groups of things, I can say we have 3 groups of a plus 2. And we can just rewrite this without brackets. So we could say if I have 3 groups of a plus 2, if I have 3 groups of a plus 2, I can rewrite this as a plus 2, one group, plus a plus 2, another group, plus a plus 2, another group. Well, if I just count them all up and I just went to repeated addition, okay, I just went one level lower than multiplication just so that I can understand what's going on here. Well, I can count my 3 A's. There's my A, there's 3 A's. And I can count my 6, 1, 2, 4, 6. So I end up with plus 6. And this is, I don't have to be able to add first inside the brackets if I can just kind of break it down into this like this. Now there's a much easier way to do this. So we can say that, well, we can distribute. So we can rewrite this 3 times a plus 2, and we can do the same process that we did here. And we can show that with our area model as well. So I can model this with length. So we have 2 models. We can talk about groups, but we could also talk about multiplication as area. So this is length times width. So a plus 2 becomes my width, 3 becomes my length, 3 times a, 3 times 6. And I can model this by showing that I can distribute that multiplier into the brackets like that. And that ends up giving us 3 groups of A plus 3 groups of 2. And whether we're using the grouping model or we're using the area model, it is consistent. We are able to distribute that multiplier across the addition sign here. And we can count up these different parts separately and keep that count separate, which is really important to be able to keep counting of A's and counting of 1's separate.